Use of exponents to express small numbers in standard form. In this lesson, we shall define exponents and express any given number in the standard exponent form. Come on. Let us get started. Introduction to Exponents. Hi students, welcome back to our class. Today, we are going to discuss an interesting topic. But, before moving on to the topic, let us play a game.
Wow, that's interesting. Let's start the game.
The game is, I will give you a set of information, you have to listen to it carefully and tell me what it is when I ask you.
This is easy, we can tell you.
Okay, the rules in this game, you should not write anything but you should remember them. Also you should recall and write when I ask you to do. Is the rule of this game clear to you?
Yes, ma'am.
Students, listen carefully. The set of information you should remember is, the height of a cup is 11 centimeters. The height of Mount Everest is 8,884 meters. The diameter of a wire on a computer chip is 0.000003 meter. The distance from the Earth to the Sun is 149,600 lakhs meters. The size of a plant cell is 0.000127 meter. The thickness of the 8th standard mathematics book is 20 millimeters.
Ma'am, this game is not easy as we thought.
Yes, but in general, can you tell me what the information was about?
It was about the height or weight of an object.
Yes, it's about the height, diameter, size and thickness of some objects and the distance between planets. Can anyone recall any number that was told in the set of information? If you remember, please write it in your note.
Yes, ma'am.
So, let me guess what most of you recalled. I know most of you could definitely recall that the height of the cup is 11 centimeters and the thickness of the 8th standard mathematics book is 20 millimeters.
Yes, ma'am.
Do you know why you couldn't recall the other numbers that were told? The reason is that they are either very large or very small numbers with many decimal places. Even while solving problems, such values are difficult to handle.
Yes, ma'am, they are hard to remember.
So how can we remember them easily? Is there any method for simplifying them?
Yes, to remember them easily and make problem solving easier, we can use the concept called exponents. Expressing any large number or small number in exponent form helps us to handle them easily. In this lesson, we are going to learn about exponents and expressing any number in its exponent form. What is an exponent? Let us first discuss what an exponent is. Consider 2 to the power 3. Here 2 is the base and 3 is the exponent. We read 2 to the power 3 as 2 raised to the power 3. Thus, the exponent is a quality representing the power to a given number or expression. 2 to the power 3 represents that 2 has occurred 3 times. Thus, these exponents actually represent the number of times the base occurred in the expression. For example, 3 to the power 2 represents 3 has occurred 2 times. Similarly, we represent 3 to the power of 3 and 3 to the power of 4. Now, let us discuss the types of exponents. There are actually 2 types of exponents. One is positive, and the other is a negative exponent. Positive exponents are used for larger numbers or integers, whereas negative exponents are used for small or fractional numbers. Let us move on to positive and negative exponents. Powers with positive exponents. We now know that 100 can be represented as, say 10 square. Since 100 is twice the multiple of 10. Now can you represent 10 lakhs in exponent form?
Do we need to find the multiples of 10 in 10 lakhs, ma'am?
Yes, since it is definitely a multiple of 10, the other easy way to estimate is to count the number of zeros. Let's count the zeros together.
10 lakhs contain 6 zeros, ma'am.
Good, so 10 lakhs can be represented as 10 to the power 6. Here the value 6 represents that the number of zeros in 10 lakhs is the exponent and the base is 10. Can we try to express the number 120 lakhs in exponent form?
Yes, ma'am, we have 6 zeros in it.
Correct, we have 6 zeros. So, we have found the multiples of 10 in 120 lakhs. Thus, we can express 120 lakhs as 12 into 10 to the power of 6. Let us see one of the applications of exponents. As I have stated that the distance from the Earth to the Sun is 149,600 lakh meters, now let us represent this in exponent form.
There are 8 zeros in it, ma'am.
Good, yes, there are 8 zeros in it. So, we can express 149,600 lakhs as 1,496 into 10 to the power of 8. Similarly, we can do for any large number to express it as an exponent. Here we can see that exponents are positive. Let us now discuss about negative exponents. Powers with negative exponents. Before discussing about negative exponents, can anyone recall what a fractional number is?
Ma'am, representing any number in the form of p over q where q is not equal to 0, is called a fractional number. Here p is called the numerator, and q is called the denominator.
Very good. Some examples of fractional numbers are 1 over 10, 3 over 10, minus 1 over 107 over 1000. The denominator of every fractional value can be expressed in terms of its exponent with negative power. For example, consider 1 over 10 has only one 10 in the denominator. When we take it to the numerator, it is expressed in the form of 10 to the power of minus 1. Thus, 1 over 10 is represented as 1 into 10 to the power of minus 1. Consider the other example 3 over 10. Since 10 is in the denominator, when we bring that to the numerator the power becomes negative. Thus, 3 over 10 can be rewritten as 3 into 10 to the power of minus 1. The next example is minus 1 over 100. This denominator can be represented as 10 to the power of 2. When it is taken to the numerator it becomes minus 1 into 10 to the power of minus 2. Next, consider 7 over 1000. The denominator can be rewritten as 10 to the power of 3. When it is taken to the numerator, it becomes 7 into 10 to the power of minus 3. Now, let's see one of the applications of negative exponents. The diameter of a wire on a computer chip is 0.000003 meter. Now, can you guess how we could represent this as an exponent?
No idea, ma'am.
It is easy. Now, rewrite the decimal value in terms of fractional values.
Yes, ma'am. 0.000003 is 3 over 1 lakh.
Good. Can you explain it to the other students?
Sure, ma'am. Friends, first count the number of places after the decimal point. Here we have 6 places. So the fractional value of 0.000003 is 3 over 10 to the power of 6. Thus the exponent form is 3 into 10 to the power of minus 6.
Good. Thus the number 0.000003 meter, which is the diameter of a wire on a computer chip, can be represented as 3 into 10 to the power of minus 6. Relation between positive and negative exponents. Students, we have discussed positive and negative exponents.
Ma'am, I have a doubt. Is there any relationship between a positive exponent and a negative exponent?
Good question. Yes, there is a relation between them. They are the multiplicative inverse of each other. Any number x to the power of y is the multiplicative inverse of x to the power of minus y. X to the power of y is equal to 1 over x to the power of minus y, and x to the power of minus y is equal to 1 over x to the power of y. Can anyone find the multiplicative inverse of 2 to the power of 5?
The multiplicative inverse of 2 to the power of 5 is 2 to the power of minus 5.
Find the multiplicative inverse of 5 to the power of minus 2.
The multiplicative inverse of 5 to the power of minus 2 is 5 to the power of 2.
Correct. Do the following as homework and try it out later.
Okay, ma'am.
Find the multiplicative inverse of the following: 10 to the power of minus 7, 5 to the power of minus 6, 1 over 10 to the power of 8, and 59 to the power of minus 5. Expand the number using exponents. Let us now see about the expansion of a given number in its exponent form. Consider 1025.
No zeros are here to count. So, what should we do?
Yes, here we don't have zeros. From previous classes, we know how to express any number with its decimal places. Say, the number 1425 can be represented as 1, its decimal place is 1000, so 1 into 1000 plus 4 into 100 plus 2 into 10 plus 5 into 1. Now each expanded term can be expressed as exponents. Thus it can be expanded, and 1425 can be represented as 1 into 10 to the power of 3, plus 4 into 10 to the power of 2, plus 2 into 10 to the power of 1, plus 5 into 10 to the power of 0. Students, can you try expanding the number 2542?
Yes, ma'am. 2542 can be represented as 2 into 10 to the power of 3, plus 5 into 10 to the power of 2, plus 4 into 10 to the power of 1, plus 2 into 10 to the power of 0.
Very good. Now let us expand 3625.36. The expanded form of 3625.36 is 3 into 1000, plus 6 into 100, plus 2 into 10, plus 5 into 1, plus 3 into 1 over 10, plus 6 into 1 over 100. Now each expanded term can be expressed in terms of its exponents. Thus, 3625.36 can be represented in terms of exponents as 3 into 10 to the power of 3 plus 6 into 10 to the power of 2 plus 2 into 10 to the power of 1 plus 5 into 10 to the power of 0 plus 3 into 10 to the power of minus 1 plus 6 into 10 to the power of minus 2. Thus, we have learnt to express large numbers, small numbers and any other number in the exponent form. Now, we are going to learn how to express them in standard form. Expressing numbers in standard exponent form. A standard form is a way of expressing a fixed term using decimal values. We know that we can rewrite 58.753656,789 as 58.7537 by rounding till 4 decimal places. Similarly, we can rewrite any exponent in its standard form. It is expressed as y.b into 10 to the power of c, where y is an integer, b is the decimal place and c is the exponent. Let us understand the concept by solving a problem.
Okay, ma'am.
Express 250 lakhs in the standard exponent form. First rewrite 250 lakhs in exponent form by counting the zeros. Here, we have 6 zeros. Therefore, 250 lakhs can be written as 25 into 10 to the power of 6. To convert 25 to a decimal number, multiply and divide by 10, so 25 into 10 to the power of 6 is equal to 25 divided by 10, and multiplied by 10 to rewrite as a decimal into 10 to the power of 6. Now, this is in the standard exponent form where a is equal to 2, b is equal to 5, and c is equal to 7. Try to express 0.000008 in the standard exponent form.
Ma'am, the number of places after the decimal point in 0.000008 is 6.
0.000008 is equal to 8 over 10 to the power of 6, which can be written as 8 into 10 to the power of minus 6. We know that the standard decimal form is a point b into 10 to the power of c. Thus we can write 8 as a decimal by multiplying and dividing by 10. 8 into 10 to the power of minus 6 is equal to 8 over 10 into 10 into 10 to the power of minus 6. This is equal to 0.8 into 10 into 10 to the power of minus 6. We know that the same base with different powers can be written as the base with the power sum. So, 0.8 into 10 to the power of minus 6 plus 1 is equal to 0.8 into 10 to the power of minus 5.
Okay, ma'am.
Conclusion. Students, now we have discussed the exponents, and expressing any number in the form of exponents. This helps us to recall any larger or smaller number easily. This also helps to simplify to solve the problem involving them. Summary. Students, in this lesson, we have discussed what exponents are, expressing numbers using positive and negative exponents, expanding any number in terms of exponents, and expressing numbers in the standard exponent form.